Hey everybody, in this video we're going to talk about a topic that you probably have a little bit of information on already. It's called Venn diagrams. Venn diagrams are a way that you can display visually a bit of information about a set population of people, breaking them into separate categories. Separate but overlapping categories at the same time. But let's start with a nice simple one. So consider that we have 100 juniors and 38 of these juniors take art. So if we want to display this, we could draw a box and a circle, right? And this circle represents the 38 people who are taking art. And then the box is going to represent everybody, all the 100 juniors. So that we call our sample space. So, and we use the term U for our sample space. And the letter A, you can use art. You can actually use anything that you'd like for that. I chose A because art starts with A. But this box U, it represents the entire sample space. So if we've got 100 juniors, but 38 of them are already accounted for in the art section, that leaves us with 62 people, 62 juniors who are not taking art. So in this box, in total, we are counting 100 juniors. In the circle, we're saying that just 38 of them are taking art, and outside the circle, 62 are not taking art. So the way that we do this is we say the number of students taking art, or the N of A, is 38. And if we want to say what is the probability of choosing a student out of this 100 who is taking art, we say the probability of A is going to be 38 over 100 because there's 100 people total represented by this box. So what is the probability that we randomly choose somebody that happens to be taking art? So once we simplify that, that comes down to 19 over 50, or of course you can convert that to a decimal as well if you'd like. The complement of A, or taking art, is not taking art. So we say that with the notation of A prime, with a little, almost like an apostrophe next to the letter that you're talking about. So the complement of A is A prime, and that's 62. So 62 people are not taking art. So N of A prime is 62, so what's the probability of people not taking art? Well, that's 62 out of 100, or 31 out of 50. An interesting thing to note here is that the sum of the probability of people taking art and the sum of the probability of people not taking art is 19 over 50 plus 31 over 50, which is actually 50 over 50, or 1. So in this case, 100% of the people are either taking art or not taking art. And that makes sense based on the visual that we've given here. But something to keep in mind is that P of A plus P of A prime, the probability of A plus the probability of A prime, not A, is equal to 1. This is kind of a fundamental rule of probabilities, that the complements of each other add up to 1. All right, so let's expand on this scenario a little bit, and we'll take into consideration not just students taking art, but students taking biology and some students who are taking both subjects. All right, so now because we've got two subjects that we're going to talk about, we're going to have two circles. We'll have one that represents art and one that represents biology. Now, the overlap where these two circles intersect, that's where we're going to talk about the students who are taking both subjects. So 16 people are taking both subjects, so that means, well, if we had 30 people taking biology, then 30 minus 16, or 14 people, are only taking biology. And similarly, 38 minus 16, right, the number of students taking art, we've only got 22 people taking art only. But between the three of them, we have all of the students who are taking art or biology, or both. And then if we want to find out who's left in the sample space, we just subtract each of these values from 100, and we get 48. So that's who's left, who's not taking any of these subjects. All right. So the number of A and B, this little symbol here, this is called the intersection, and it means and. So we want to know the number of students who are taking art and biology. So art and biology, well, that's 16. So what's the probability of students choosing a student who's taking art and biology? Well, again, we're going to take 16, or the number of students who are taking both, excuse me, and divide it by the number of students in the sample space, in the entire sample space. So that's 16 out of 100, or 4/25. Now, a common thing that happens is sometimes people think of n of u as just that 48, but you have to remember that u represents the entire box, everybody inside that box. There's just 48 students who are not taking one of those two subjects. All right, so let's look at this example and expand on it a little bit more. What is the probability of A and not B? Okay, so now we're going to use the complement of B, so those things that are not B, but are A. So everything that is A, and then those things that are not B. So A is all of A. This is not B, or excluding B. So we have to start with what is A. Well, A is the whole blue circle, and we want to exclude B, so it's just going to be this space right here. So we're going to look at 22 out of 100, or 11 out of 50. All right, what if we try this again with another scenario? What if we say we've got P of not A and not B? So again, the intersection of everything that is not A and everything that is not B. So everything that's not A would be B and the outside portion, the 48. Everything that's not B would be A and the outside piece. So if we want the intersection, if we want everything that is none of A and everything that is none of B, then we're going to have just the outside piece left over. So our probability is going to be 48 out of 100, or 12 out of 25 when you simplify. Okay, so all of this, again, is intersection. When you've got that little kind of rounded N on there, that's intersection. And you can think of that as the overlap. So a lot of times you're going to think about how these things overlap with each other. Another way that I say it is AND statements. So both things have to be true with an AND statement. Okay? So that's intersection. Now let's look at a slightly different scenario. What is P of A U B? All right, well now this means union. So this is kind of like saying or both things. Either one could be true, I guess I should say. That's probably a better way to say it than both. So either one is true. So if we are looking for the probability of A union B, then that's going to be all of A and all of B. Either one is true, one or the other, right? So we've got 22 plus 16 plus 14 all over 100. We can simplify that down to 13 over 25. All right, so that's both things happening, or. So either A or B, right? All right, one last example here. So let's look at the probability of A union not B. So A union not B. So A, we've got our blue circle, but not B. All right, so we cannot exclude, or we can't include B. So that's just going to be this bit and the outside bit, because not B is also all of that outside piece, right? Not B is not only A, but it's also the outside. So we're going to have 22 plus 48, 70 over 100, or simplifying to 7/10. Okay, so to summarize, union is when you have both things happening, and you can say that it's an or statement, and or might be a better way to say it than both, because or means either A happening or not B happening. Either one of those two things is okay. Versus our intersection. Our intersection is where we have overlap, and that's why I say both might not be the best way to say it, because both things are happening at the same time, but that could be confused with overlap. So really, I like to think of the or statements and statements. Or means either this is true or that is true. I don't care which one. And means this is true and this other thing has to be true. So I have to look for the specific spot where both those things are true. Okay, so that's kind of the way to think of them. And I tend to think of union union as my OR piece, because union has this U in it, and the intersection has an N in it for the intersection, or and that's got the N, the kind of an N looking piece. So hopefully this helps with some of the different scenarios that you might come up with Venn diagrams. They definitely can get more complicated than this, so but hopefully this helps, and I'll talk to you soon.